problem, they ask us to look at this rectangle here and find which image shows a 90-degree clockwise rotation about the origin. Okay, so we talked about this in other videos, but a rotation of 90 degrees will change your point from xy to negative yx. And let's look at why that makes sense and then apply that to this problem. So here is my y and x axis. Let's say we have a point like 2, 1. So here's the point 2, 1. And we'll label that. Here's the origin. Okay, so here we're actually rotating 90 degrees in a clockwise direction. So a clock ticks this way. So we're going to rotate that way in terms of the origin. As a reference, we can draw a line from the origin to that point to see that, okay, if that's our line there, our new line to our new point should form a 90-degree angle with that line. So like maybe right here. That's an estimation. And here, what's this point? I have 1, negative 2, right? And you can see the 90-degree angle right there. So 1, negative 2. So what happened? Well, here our y value is 1, and now it's our y value over here. And here our x value is 2, and now the x value is negative 2. So this typically is what you're given for the rotation of a 90-degree angle. But that is assuming that positive 90 degrees is actually this way, right? Here, we're actually going the other way. So instead of thinking of this point typically as being rotated 90 degrees this way, as it would be ordinarily, we're rotating 90 degrees this way, in the clockwise direction. So one way to think about it, as I went over in other videos, we're actually rotating this way 270 degrees. That's almost a full circle. That is the same thing as rotating 90 degrees in this direction. They both end up meeting at the same angle. So in fact, this formula is a little bit different. This is a rotation of negative 90 degrees, and xy is going to be rotated as positive y, negative x. And that's this point is over here. So if we look at any point here, we have 6, 2. It's hard to read, but that's 6, 2. We're looking for the graph with what point? Well, following this formula, it should become 2, negative 6. Let's see if we can find that. 2, negative 6. There it is. And you can see that this rectangle does look like it was turned 90 degrees from this rectangle. So we started off here, and then we turned it like on a pin almost, as if there's a pin right here. Take the rectangle, turn 90 degrees this way, and we will get this rectangle. So the choice here is A. So again, the original formula I put up here was for a rotation of positive 90 degrees. But here we have a rotation of 90 degrees in the clockwise direction, which is really a rotation of negative 90, or a rotation, right, of positive 270 degrees. That's also for this, this formula also applies. And you can see here, if we started and went 270 degrees this way, counterclockwise is typically the positive direction. That would be the same thing as going negative 90 degrees this way. If you think about y, well, here's 90 degrees, here's 270, that's a full circle. So in fact, both approaches give you the same formula, positive y, negative x. Okay, I hope that helped.